on your homework check, it does say for 2.3 that we're going to do numbers 53 and 59 together. I really like question 53 because it reminds me a lot of a math team question, but by default, that also reminds me of an SAT question. So this is a question where they give you like a mystery term of k, and you got to figure out what's going on such that the remainder comes out to 0. So there's a couple of ways we could do this. One is more systematic than the other. Sometimes kids can just muscle through this question, but this would be a really fabulous question for, you guys know the gridded response part of your SAT where you got to like bubble in the numbers? This would be a perfect question for something like that. So for us, what we know about remainders coming out to 0 is we have two choices, long division and synthetic division, and most of you should be leaning towards synthetic division. That would be a smarter option for us today. So if the divisor is x minus 2 and I go to set up synthetic division, what goes in the little box here? The solution to this, which would be positive 2. And then you're supposed to set up all the coefficients. So starting with the lead term. So you have a 1, and then this is kind of weird. You have a negative k, and then a 2, and then a negative 4. And you do want to make sure that you have all your coefficients listed. So whatever the degree is, you should have one more coefficient than that. So degree 3, you should have 4 things, which it does. All right, so here we go. If we perform synthetic division, you bring down the 1, and then you multiply. So we get 1 times 2, which is 2. And this is where it gets kind of weird. You would add these together, and you would get either negative k plus 2 or 2 minus k. It doesn't matter to me. And then if we were to multiply this by 2, you would get negative 2k plus 4. So the process isn't different. We just have a little bit of unknown algebraic components going on here. So if you add these together, you have negative 2k plus combine the 2 and the 4, so make it a 6. And then if you were to multiply that by 2, you get what? A negative 4k plus 12. And then if we add these terms together, you have a negative 4k plus 8. But remember at the beginning of the problem it said, figure out what k has to be so that our remainder is actually 0. So algebraically speaking, we got this as a remainder, but they want it to come out to a 0. Well, guys, you just need to solve that. So subtract the 8 from both sides and divide by negative 4, and you get k must be a 2. That surely was not the only way to get that answer. Some kids work from the end of the problem, call that a 0, and kind of work backwards through the synthetic division. That's kind of a neat way to do it. It's the morning, and you guys aren't feeling too creative, so I just went through it. All right, let's look at the next question. 59 on that same page, I believe. And I didn't get a picture of the textbook's problem, but they did give you a graph. If you weren't given a graph, the first thing you would do is you would type this on your calculator in Y1. I'm not going to make you do that because this one has an atrocious window. So I'm just going to steal kind of sort of what's going on in the book here. Right here, which is negative 6. The graph, whoops, there is a very obvious x-intercept. So that's going to be important to me in a second. And then the graph actually goes up to like 5,000 or something. That's why I didn't want you guys to bother graphing this. Your window would be huge, right? So it does some weird stuff, and then it comes back down, and it crosses, let's see, it almost looks like negative 2, but it's not quite negative 2, so I'm not going to call that anything. We're going to find that another way. And then, it's a little confusing what's going on here, but it kind of does this, and then it keeps going up through. So, on the graph I can tell that something happens at x equals 2, and something happens at x equals negative 6. Does anyone think they know what's going on when it kind of hangs out like this, though? That's a weird idea. We haven't really seen that. It's probably some multiplicity going on, right? And the way they gave the picture in the book, it's zoomed really far out because of that 48 or 5,000 window that they had to use. So I'm not really sure if it bounces and then comes back. I'm not sure if it like goes through with a multiplicity of 3. And I don't really care because what I'm going to do is I'm going to try some synthetic division, and I'm going to work this down to a quadratic. Once it's a quadratic, we can handle it. but I'm going to have to do synthetic 3 times. So I'm going to start at -6 just because I feel like it. That's the first thing I'm going to put in my synthetic division box. And then your coefficients are, let's see, 6. Oh boy. Please have your calculators handy. I'm going to need your help in a minute. Oops, 840. And then before I get started, make sure we're not missing any terms. 1, 2, 3, 4, 5, 6 terms on a degree 5, so that makes perfect sense. All right, let's do this. Bringing down the 6, multiplying by 6 times -6 is a -36. And then this is where we should be able to add things together, but your teacher can't today. Is it 23? -23, that would be good, yep. And I'm no longer doing mental math. What's -23 times -6?
138.
Thank you. And then -153 plus 138?
Negative.
Thank you. And then -15 times -6?
90.
Positive 90. And then 54 plus 90?
144.
Thank you. 144 times -6?
Negative 864.
Okay. What's that? -140? Okay. And please tell me that's positive 840. Oh, good. Okay. So that should have come out to a remainder of 0 because of our work yesterday. Remember, when you do synthetic division on a root of a polynomial, the remainder is 0. The problem is we're still at what's called a quartic. That's definitely not a quadratic, so we got to do this again. So when I kind of go back and investigate the graph, I think there's some multiplicity happening at x equals 2. So I think we should go ahead and do synthetic division at 2. And then I think we're going to try it again and see if it works out. Now the way I'm going to know if it worked out is because the remainder is going to keep coming out to 0. So fingers crossed that this one works. Here we go. Bringing down the 6. Oh boy. Let's see if I can do a little mental math here. -23 plus 12 is -11. Okay. And then -11 times 2 is -22. -15 plus -22 is -37. -37 times 2 is -74. Oh boy, I'm on a roll. Here we go. And I'm about to, well, that's 70, right? What is it? I think this is 70. Okay. 70 times 2 is positive 140, and then, yep, that comes out to a remainder of 0. So, yay us. Okay, problem is we're still at a cubic, and I don't really feel like trying to factor this cubic. I don't even think I know how. So we were pretty certain by the graph that something weird happens at x equals 2, some sort of multiplicity. So let's try it again on this new and smaller polynomial. And we'll know that we're on the right track if we get a remainder of 0. So let's see what's going on. All right, that's a 12. Add them up, you get a 1. 1 times 2 is 2. Oh, this should work. Add them up and you, oh, yeah, no, yes. -35, and then that gives you a -70. Okay, good news. Whew, that was really tough for me for some reason. All right, so the problem is we're still not done, because what we have right now are the coefficients to our remaining quadratic. The good news is we can handle quadratics. So the directions, you probably don't remember what they are at this point, but it did say to factor completely. So we're going to have to figure out if this factors. I'm thinking yes. Let's find out. You want to try 6 and 1 or 3 and 2? Remember, we have an eraser. Oops, not 3 and 3 though. If we need to go back and fix it, we will, but I'm pretty sure 3 and 2 works. 7 and 5. You put a 7 here and a 5 here and make the 15 positive. Would that work? Okay, good. So we're good? Like our answer is this? No! Because remember, the very original problem was a degree 5. Right now I'm looking at a degree 2. So where are the other 3 factors? 14 and 15? Is that what you're asking about? Alright, so the x minus 2 is the factor from this last division. I'm just going to work my way back up. And then we had another x minus 2, so I'm going to put a squared on that one. And then we had, whoops, a root of negative 6, so his factor would be x plus 6. And then before I walk away from this question, I just want to make sure things are working out. I have 1, 2, 3, 4, 5 x terms multiplied together, so that'll be x to the 5th. And then if I look at my coefficients, 3x times 2x times x times x times x would be 6x to the 5th power would be my lead term, which was supposed to be 6x to the 5th power, so we're good to walk away. That was fun. All right, so that was kind of a hybrid of yesterday's lesson, the first part of yesterday's lesson, and then 2 days ago, the end of that lesson. So remember, we talked about all these lessons are kind of bleeding into the same fundamental theorem of algebra. So let's move on in our lesson for 2.4. I think we are on the back side of worksheet 6, so 6b. We had just finished talking about the fact that when you have a complex or a irrational root, they show up in complex pairs, in conjugate pairs, I should say. And I'm not going to be too tricky where I give you things like 2 plus square root of 6 like we had in the example before. Usually our conjugate roots are going to be imaginary complex roots. But you do have to know that they show up that way. So, this example, they're stepping it up a little bit. It's a degree 4, so I know in theory I should be finding 4 roots. They might have multiplicity, but there's going to be 4 roots. And the only clue they gave me was that one of the roots, one of the zeros, is 2 plus I. So that is a complex number. So here's what we know, guys. If 2 plus I is a 0, that means his conjugate of 2 minus I also happens to be a 0. So I technically have 2 clues right now. So in my head I'm going, that's great, because I'm going to be able to take a quartic, knock it down twice, I'll have a quadratic, and then I can use my Algebra 2 brain. Now, this is going to be very challenging for kids. This is how you write a factor. You knew this. You take x and then you subtract the root. Well, what's happening here is the root is a binomial, 2 plus I. So what I want you guys to do is just literally leave it like that. Parenthesis x minus, and then open another parenthesis, 2 plus I. So when you go to write the other factor, it'll be x minus, and then this time it's 2 minus I. So the root, if it's more than one term, like we have here, just keep it in an extra set of parentheses. You don't need to do any distribution or anything weird. All right, so here's what I need you to do. We got to figure out what this is when we do distribute it together. This is not going to be very fun to distribute together, but what I want to do is kind of take you down memory lane for a minute. There's a pattern to these easy factoring questions. Let's see. Whoops. So when you guys first started to learn how to factor, your teacher taught you about diamonds. Remember learning about diamonds? And those factoring questions were like the really easy ones, and the thing they all had in common was that this first number was a 1. So if you are looking at an easy factoring question, there is a pattern that always applies. And that is this last number here is the product of your two n0 factors. And what's this number here? It's the sum, kind of. Okay? It's going to be well, we'll talk about it in a second. Let's talk about the roots. If you went ahead and factored this, it factors into x plus 2 times x minus 3. Or plus 3, excuse me. What are the solutions to this? X equals negative 2 and x equals negative 3. So let's call this the product of the zeros. But this number here would be the opposite of the sum of the zeros. So, like in factoring, you guys knew the numbers had to add up to positive 5, but if you think ahead in the problem and you actually solved it, that number is the opposite sign of the sum of your zeros. Here's why this is so important, guys. If I'm supposed to write this in a trinomial form, I have 2 choices. I can either accept and use that pattern, or I can FOIL this to death. Let me just tell you, foiling this is not fun. So, let's do this the easy way. I know the first number is going to be x squared. and then we're going to have this middle term, and then we're going to have a third term. Well, the middle term is the opposite sign of the sum. So let's go figure that out, guys. Your roots were 2 plus I and 2 minus I. So what would happen if you added those roots together? You'd get 4. And then if you took the opposite sign of that, you'd get -4. That's what I want you to write down right here. Throw an X after it. Okay, this red blank is going to be the product of your two zeros. So for us, what would happen if we multiplied 2 plus I times 2 minus I? Well, good things are going to happen, right? Because those are conjugates. You get 4 minus I squared. But guys, what's I squared? It's really -1, so you have 4 minus -1. You have a 5. Okay. That's how I want you to try, instead of actively foiling those horrible polynomials together, if you can use this shortcut, you'll be in a much better place. Trust me. Yes. So, yep, so the zeros. So what you do is you take your two zeros, your two complex zeros, and you add them together. So like 2 plus I plus 2 minus I. The i's cancel each other, and you get a 4. But the trick to this middle part is whatever answer you got to give me the opposite sign for it. That's the way the pattern works. Okay? So that's why we went with -4. Okay? Real quick, let's just try another one. What if your zeros were 3 plus, or sorry, what if your, back up, Abruzzo. What if I told you some mystery polynomial had a 0 at 3 plus 2i? What else do you know? You also know it has a 3 minus 2i because they come in complex conjugate pairs. So instead of taking the long way of trying to like foil this mess together, because this would be horrible, let's take the shortcut. So the shortcut's going to be, I know the first term is x squared, and then we're going to have that green thing in the middle with an x after it, and then that red thing at the end. All right, so who remembers how we find the green thing? You take the opposite of the sum. So for us, that would be the opposite of, what happens when you take 3 plus 2i and you add it to 3 minus 2i? You get -6. And then the red blank is, remember, it's the product. So you're just going to multiply them together. Well, conjugates work out really nicely when you multiply them together, huh? 3 plus 2i times 3 minus 2i. Let's see, that becomes 9. I know the outside-inside cancels on conjugates. And then you have a minus 4i squared. But y'all know that I squared is really -1. So this really says 9 plus 4. So this last number is a 13. Okay. A positive 13. I should have put a plus sign there. So that's real tricky. I know. That's tough. All right. But we're not done, guys. Remember this whole problem here? We have to find the other factors. Oh, man. All right. So good news is I can extend my page for the rest of my life. You can't. Here's what we have to do. We're going to use, notice, long division. Because, guys, I really don't want to do synthetic division with 2 plus I, and I really don't want to do it again with 2 minus I. So this is a case where it is smarter to just go ahead and do long division. I'm going to take our original polynomial, and we're going to divide it by this trinomial that we just came up with, which is the factors, the foilization, if you want to call it that, of our two factors, our two zeros. All right, here we go. Find some room somewhere. Sorry, maybe off to the very far right side. Can you just use the whiteboard? Sure. All right, x to the 4th minus 5x to the 3rd plus 3x squared plus 19x, ooh, minus 30. And we're choosing long division with this new and improved that quadratic we just came up with. So just so we're clear, this quadratic is a combination of the two complex zeros that we were told. All right, here goes. Long division, start with the division part. X to the fourth divided by x squared is x squared. And then if you multiply x squared into this divisor, you get x to the fourth minus 4x to the third plus 5x squared. And if you have another colored pen, this is where I suggest you use it if that's all you have. That subtraction, parentheses, and big fraction line. If that's in another color, that helps break up your work a little bit. All right, lead terms should always cancel in long division. Careful here, guys. -5 minus -4 is a -1x to the third. And then 3x squared minus 5x squared is minus 2x squared. And then don't forget, you got to bring down this last term, or next term, I should say. Now we get to go again. All right, here's your new problem, -x to the third. Now it's being divided by x squared, and that gives us a -1x. Okay, that -1x gets multiplied in. So -x to the third plus 4x squared minus 5x watch your subtraction here. All right, so we have, let's see, lead term cancels, it should. -2x squared minus 4x squared is -6x squared. And then 19 minus a minus 5x is plus 24x. There is still one more term. The good news is it's our last term, so we are done after this step. Now guys, what should our remainder be if I was claiming this was a factor? The remainder better be 0, or I'm going to be pretty mad, because that means you didn't catch my mistake. All right, let's see. Divide -6x to the second power. Now that's being divided by the x squared. And you get -6. If you were to take that -6 and multiply it into the divisor, you get -6x squared, oh good, plus 24x, minus 30, and then remember you're subtracting all that. Y'all just breathed a sigh of relief because you noticed your remainder was 0. Good news. We're almost done, but not quite. Because that thing up top, that blue x squared minus x minus 6, that is the remaining factor, which you can factor. So, how are you going to factor x squared minus x minus 6? Very easily, Mrs. Abruzzo. That's an x minus 3 and an x plus 2. So, you can't really read it because I crossed off half of it. But those were all of your factors. Somewhere in this line, they wanted me to write all my zeros. So what were your last two zeros that we just kind of stumbled upon if you were to solve these factors for me? X equals +3 and -2. Very good. Oh, that was fun. I hope you have like 7 of those on your homework. That was one problem. How horrible was that? All right. Sorry about that. Let's look at another one. Write a polynomial of least degree with real coefficients. And then this is annoying. They want it in standard form. And I kind of forgot about this on the last question from yesterday. I was supposed to multiply everything and not leave it in factored form. Yesterday's problem wasn't bad. This one's going to be awful. All right, here we go. All right, guys, you have, right now it looks like I have 3 clues, but one would argue you actually have 4 clues. Tell me why. So there's a 0 at -4. There's a 0 at 1. There's a 0 at 4 plus I, or where else is there a 0? 4 minus I. Okay, here we go. Name your polynomial whatever you want. I'm going to go with p of x. What does the factor look like when the 0 is -4? The factor, go backwards, looks like x plus 4. And then the factor for the 0 of x equals 1 would be x minus 1. Okay, here we go. This one. When you write this as a factor, you're going to write x minus, and then another parenthesis set, 4 plus I. Remember that weird double parenthesis thing we had on the last question? Same thing here. And then this one, this next one, is going to be x minus, this time 4 minus I. Okay. Here's the problem. This is a major problem. This is like what we were just doing on the last couple questions where we were trying that little sneaky pattern out. I want you to try to use that here. So I know the first term is going to be an x squared. That's not going to be too troublesome for us. My middle term is going to be the opposite sign of what happens when you add these together. So what would happen if you add 4 plus I plus 4 minus I? You get 8. So the opposite of that would be 8, and then we'll throw an x after it. Negative 8x. And then the last number is the product. So think about what would happen if you multiplied 4 plus I times 4 minus I together. So a little conjugate action. You get 16 minus I squared. But we know I squared is really negative 1. So that's 16 plus 1. So it's 17. Oh boy, here we go. We're not done. These red things right here, they are currently binomial factors. If it said leave in factored form, which it does on your test, by the way, so yay. Leave in factored form, please do, but this said write it in standard form. So we're going to have to multiply all this hot mess together. Let's do this in stages. You already multiplied 2 of them together. That was good. Let's go ahead and multiply these 2 together. Let's see. What is that? Plus 3x minus 4? And we're still not in standard form because we have 2 quadratic factors right now. You got to distribute everybody. Here we go. X squared times, I'm going to take this x squared and distribute it to everybody first. So we got x to the 4th minus 8x to the 3rd plus 17x squared. I'm going to do the same thing now with the 3x. Throw him into there. So we got plus 3x squared minus 24. Oh, sorry. 3x to the 3rd. Sorry. Minus 24x squared plus, is that 51x? Check my math. 3 times 17 is 51. I love how you guys trust my mental math. Haven't you learned? Okay. All right. And now we're going to do the same thing with the negative 4. Throw him into everybody. You have a negative 4x squared plus 32x. 70. No, 8. No, 68. I give up. 68? 68. Okay. So close. Except now we have to go through and collect all our like terms. Alright, so x to the 4th. There's only one of those in the problem. Go grab all the x to the 3rds, if I can find them all. And that becomes, what, a minus 5x to the 3rd? Grab all the x squareds. Should be 3 of them. Where are we at? Negative 7. Is that negative 11x to the 2nd? Something like that. Come on. Alright, and then, please speak up if that's not right. You're going to embarrass me on YouTube. Alright, 51 plus 32 is 83x. What? Minus 68. Alright, how are we feeling about that answer? Are you confirming any of these numbers? Is it just me? Alright, apologies, internet. The kids are too quiet to tell me I screwed up. That's standard form. That's super fun. But did you all catch what I said on your test? I don't make you FOIL everything back out to standard form. You get to leave it in factored form. However, it does say with real coefficients. So can you leave your answer like this? Are these real coefficients? No, they got eyes in them. So you do have to take that step to, yeah, right? What are we thinking? All right. Whew, what's next? Oh, these won't be too bad. All right. Let's see, I have time to do, yeah, I think we can get both of them done. All right, this one. So through the art of Mrs. Hoffbauer already did it for you. She already graphed these for you, and this is where you would start your homework. I would either have to tell you where to start your synthetic division, or you would look on your graphing calculator to identify some easy places where it crosses the x-axis. So thank you, Hoffbauer, for already coming up with these. She found out that -6 and 4 were good things to use for synthetic division. And that's only found for us by graphing it. Okay, remember that rational root theorem where, like, here's all the possible rational roots, and if we didn't have any graphing calculators, we'd have to test until we found one that worked? I'm not going to make you do that. I will make you come up with all the possible roots, but not actually test them. All right, we're going to do successive synthetic division. So which one do you want to start with? It does not matter. Okay, -6. Jeez, children. All right, coefficients. Make sure you get all of them in order. So 1, 2, -15, 18, and -216. Okay, here we go. Bring down that 1. And now we do a series of multiply adds. So 1 times -6 is -6. Add them up. And you get -4. -4 times -6 is +24. Add those up. 9. And then 9 times -6 is -54. My mental math has lost. What is that? I'm sorry, what? -36, thank you. And then please tell me that's +216 when you multiply those. Good, and it should have been because we were claiming that that was a 0, so the remainder should come out to 0, which it did. Now, problem, we're still at a cubic. We're not low enough to do factoring, so we're going to do one more round of synthetic division. This time, on this smaller one, ignore the 0, and you're going to use x equals 4. That was the other little clue they gave me off of the calculator. So here we go, starting with a 1. 1 times 4 is 4. That's a 0. 0 times 4 is 0. You'd be surprised what kids tell me for an answer there. 9 plus 0 is 9. And then 9 times 4 is +36. So these are going to knock out again to a remainder of 0. So we can stop the successive divisions because we have whittled down to a quadratic. So tell me, what quadratic is this? This is 1x squared plus no x's plus 9. So we got to read the directions carefully here. It said, write as a product of linear and irreducible quadratic factors. So the first answer to this question is going to have these original factors from the calculator, and this is called h of x. They want those written as factors, so it was the factor of x plus 6 and x minus 4. Those were the ones from the calculator. And then they wanted an irreducible quadratic. So if you hit a quadratic that cannot be factored without the use of something weird, this is what they want right here. So for us, that'd be x squared plus 9. But then it says, tell me all of your zeros. Or sorry, product of linear factors next. One more. You can technically answer part C before you answer part B, which might be easier for some of you guys. So the zeros were -6 and 4. What are the zeros to this quadratic? What would you get if you solved this quadratic? You're going to get some i's, right? You're going to subtract the 9 over. And when you square root a -9, you get +3i and you get -3i. So we did indeed get 4 solutions, 4 zeros. You guys want to go backwards now with me though and write them as linear factors. So this first part was already fine. X plus 6 and x minus 4, those were linear factors. But can you guys help me, now that you know what the solutions are, rewrite this quadratic in factored form? What would that look like? X minus 3i, and then instead of x minus -3i, most of you would write x plus 3i. Oh boy, fun times.
How did you get the -6 and 4?
They were from the calculator, so we graphed it and we looked at where it crossed the x-axis, and probably did some tracing to confirm that it was negative 6 and 4. Usually what will happen on a test or even homework in the book or on the test, it'll say start synthetic division with x equals 5. And then you'll know that must be one of the zeros. But if not, you guys can, it might say use a graphing calculator to find a place to start. All right, one more. Here we go. On the graphing calculator, thank you, Mrs. Hoffbauer, she gave me a couple of zeros to investigate. Not that one, though. There we go. Negative 1.25 and negative 3. Well, that's fantastic. Now, clearly, negative 1.25 is secretly a fraction. Someone want to tell me what fraction that is, if it's negative 1 and a 4? Isn't it really negative 5/4? It's the same fraction equivalent. Okay, just throwing that out there. All right, this one's going to be a little challenging, and it has to do with the coefficients. All right, here we go. So, synthetic division. You're going to have to do both those numbers for successive synthetic divisions, because right now you have a quartic, and that's too big. I need to bring it down 2 levels. So, here we go. You want to start with the fraction or the non-fraction? The negative 3? All right. 4, negative 15, 43, oh boy, 577 and 615. Sure, why not? Okay, get your calculators handy. All right, I got this first one. That's negative 12. And I think I can even do this. That's negative 27. Oh, 81. Okay. 124. Yeah, all right. Now, 124 times negative 3, negative 372. And you're adding those up and you get 205? 4, 5, what? 5, yes. And then 205 times negative 3, please tell me that's negative 615. Otherwise we have done something terrible. Yep, it is. All right, so remainder of 0, good job us. But we're not done. We still have a cubic, too big. So we're going to do synthetic division on, you can call it the negative 1.25 if you want, or if you didn't have a calculator and you had to do mental math, the fraction would be easier, negative 5/4. Either way, I'm just going to rely on you guys. You're probably typing. Go ahead. 4 times negative 5/4 is negative 5. Thank you. Let's see, that's negative 32 times negative 5/4. Positive 40. Adding those up, you get 164. Oh boy. All right. Calculator help, guys. What's 164 times negative 5/4? Please tell me it's negative 205. Is it negative 205? Are you just trusting it's going to... What did I screw up now? Nope, this is 32. Yeah, this is negative 205. I think I'm okay on that number, kiddo. Whoops, why'd you go green or blue? Okay, yes, remainder 0. Good news. Now, guys, I can tell from the shape of the graph that Mrs. Hoffbauer provided us that the other zeros that we're about to find are not going to be pretty. In fact, they're going to be imaginary. Can you guys tell why they're imaginary? Because do you see a physical place where it crosses the x-axis besides the 2 that we already used? No. So if you can't see something, it's imaginary. Thus the name imaginary numbers. You guys are like, is that really their name? Yeah, kind of. All right, so guys, we do have a quadratic here. You have a 4x squared, a minus 32x, and a plus 164. Now, your gut instinct right now is to divide everything by a 4. You can, but you have to remember that you did that and bring it back later in the problem. So we're not solving right now, guys. We're just factoring. So should you be factoring out the 4? You can, but you're going to want to leave it in front. Okay, take out the 4 and tell me what my tinier remaining quadratic is. That's an x squared minus 8x plus 41. And then I was really hoping for a miracle that that would factor, but we already discussed that they're going to be imaginary factors. So This is a bit of a bummer, guys. You're actually going to need to... This is the answer to part A. We're almost there for part A. It said write as a product of irreducible quadratics and linear factors. So here's your irreducible quadratic part. And then your linear factors were... I forgot what they were. All right, so x plus 3 is the factor for the first one. And then you can write x plus 5/4 for the second one. That's fine. So that's the answer to part A. And this is a case where, I'm going to be honest, I'm going to skip to part C and get that one done first. I'm going to find the zeros. So we already found two of the zeros, guys. -3 and -5/4 were two of the zeros. How are you going to find zeros from this quadratic piece? You're going to do a little quadratic formula. All right, here we go. Opposite of b, plus and minus, square root of b squared minus 4 times a times c. Yep, that's a 1, by the way. All over 2a. It's definitely going to give you some eyes here, guys. I need to know what the discriminant is. What's 64 minus 4 times 41? One more time, kiddo. -200? -100. Okay. Well, that's not bad. What happens when you take the square root of -100? You get 10i. Now, guys, you no longer have a radical. You can take these all the way down to simplified answers. So, like, for instance, 8, 2, and 10 can all be cut by 2. So that's a 4 and that's a 5, and 1's boring, so I don't even bother with it. So one answer is 4 plus 5i, and the other answer is 4 minus 5i. That's fantastic news, except for I got to go backwards now and find the factor. All right, here's what you're going to do. You're going to leave the 4. We're going to leave the x plus 3. We're going to leave the x plus 5/4. But then there's this part, and we're going to write it as x minus 4 plus 5i in parentheses, close, close. And then the other factor is x minus 4 minus 5i, close, close. That is the most disgusting thing I could give you. I'm sorry. So you have to be a little flexible, guys, when it comes to your homework. Sometimes the roots are so horrible that I'd rather find them first and go backwards and come up with the factors. You're not going to be able to factor a quadratic that looks like this naturally in your brain unless you're like super good at weird math, which, guys, I wouldn't even try to factor this in my head. That's very difficult. I would find the solutions and then go back to the factors. Now, I'm going to tell you something else about the answers here, guys. If you look in the answer key, you might see something different. They may have taken this 4 and they might have thrown it into this fraction set, or this factor set right here. If you put a 4 and distributed it right here and here, you would end up with a 4x plus 5. So don't be afraid if you see like that coefficient all of a sudden show back up in one of the factors, because they chose to distribute it to get rid of the fraction component. Okay, so sometimes you have the right answer, but it's a little different than what I have in the key. All right, good news. You can finish 2.4's bookwork now. Tomorrow we're going to have more. We're done learning. So make sure you show up tomorrow with questions on your homework, and then we have more problems to do that are review. Getting ready for our test on, do you guys remember when your test is? Tuesday. So I'll have a review ready for you tomorrow as well.